Let's move to the beta screen by clicking this link in the top menu. Every beta coefficient from the model is shown in this table. For gender, we have 0.0244 for males. We have the sample size or weighted sample size in that band in this column, the estimated beta and the standard error of that beta estimate. The Z value is the beta divided by the standard error, and a tick or cross to show if that beta is statistically significant or not. However, the base categories, not having a beta per se, are always just ticked. This shows a tick if the Z value is greater than 1.96, or a cross if the Z value is less than 1.96. 1.96 is a magic number in statistics, as it represents the 95% cutoff for the coefficients being significant or not. Statistically significant, i.e. with a tick, means that the estimated beta value is significantly far enough away from zero that it should be included in the model. If the beta could be zero, which means that the actual beta is not significantly far enough away from zero for us to conclude that it's not zero, then that level should not be in the model. So a cross means it is not significant and should probably be excluded from the model. Evidently, gender should not remain in the model because it is not statistically significant, as indicated by a cross here. It's important to keep in mind what these betas mean, and what it means when we say it is or isn't statistically significantly different from zero. The base level in a categorical variable won't have a beta, but the other levels will. The beta is a measure of how different each level is from the base level. This table gives us a different way of looking at the same information that was in the charts that we've been looking at in earlier videos. Generally, charts are easier for the human mind to read than tables of numbers. But the great thing about this table is that you can just scan down the significant column to see what needs to be looked at. Anything with a cross means take action, because this beta is not statistically significant. Take action might mean drop this predictor from the model by unticking it and refitting the GLM in the GLM construct screen, or it might mean modify it in some way by grouping up categories like we did for highest level attended, or fitting a different shaped spline as we did for the effects of legalized gambling. Generally, you can improve the significance of the beta parameters by either improving the fit of the model, which is the alignment of the red and orange lines discussed in earlier videos, or by reducing the number of parameters, either by grouping or fitting curves through predictors, since a linear line only takes one beta. A quadratic curve takes 2 betas, a cubic curve takes 3, etc. While a categorical variable can use many more betas than that. So it's generally more efficient to try to fit a curve rather than use the categorical version of a predictor whenever it's possible to do so. The beta for a continuous variable, such as importance of faith, is labelled linear variable here, or linear spline, such as in the effects of legalized gambling. Now this beta is the slope of the line. At the risk of sounding too mathematical, for a quadratic term such as this, the beta is the coefficient of the quadratic term. A beta close to zero, or that isn't significantly different from zero, is effectively a flat line, or at least the model can't say that it shouldn't be a flat line. If it's a flat line, then whether an observation is at one end or the other of the line will have no effect on the response. So if it's a flat line, or if the beta is not significant, then this factor should not be included in the model. The most important thing to use this beta screen for is to note that a tick indicates that it probably should be kept in the model, unless we're talking about a base level, such as this, in which case it's always ticked and you wouldn't pay any regard to whether it's a tick or a cross for a base level. While a cross indicates that it should be removed from the model, or at least the variable should be modified in some way to make it significant. Once we've progressed through the modelling process, grouping levels, fitting splines, and so on, we should come back to this screen on a regular basis and confirm that any factors remaining in the model are in fact significant. Your modeling job is complete when you've squeezed as much signal out of the model without overfitting to noise in the sample data. Generally, you've achieved this when there are no crosses here and you are confident that you can't improve the model fit by adding any more predictors, i.e. you've tried to add additional predictors and they weren't significant or they didn't improve the model fit. Lastly, the intercept term, this one here, is the overall balancing item not associated with any particular predictor. Don't worry if the intercept is significant or not. In the next video, we will talk through interpretation of the model and what this intercept term means.